All right, so I'd like to do just some quick conversion process practice. Key concepts, most functions. Most functions fit this format where there's, the major function, which gets multiplied by a ratio so that the trajectory passes through the points that you see on the graph. And I think that it's very useful to know how to write equations quickly based on what you see. I don't teach transformations in my classroom. I teach change, linear, quadratic, square root, absolute value, sinusoidal, exponential, logarithmic change from a given point, provided that point is where the patterns emanate from. If there isn't a particular coordinate where a pattern emanates from, just 2 points and an asymptote take care of just about everything we're going to do. And each of the conversions, I'm going to base from coordinate 4, 3, and I'm going to have it pass through 9 and 10. And you keep an eye open on this process where a function equals its constant implies that this part of the algorithm has to equal 0. And m plus c implies that f of x has to equal 1. And it's not too hard to make functions equal 0 and equal 1. That's what we're going to find out. All right, so I'm just going to do these very quickly, 10 seconds each, I hope. Keep my comments to a minimum. You pause the video as we go along and just think about what you see. All right, and I am not going to put it in simplest form. I'm going to put it in a conceptual format. All right, so 4, 3 to 9, 10, linear. We make that 0. And we want to get from 4 to 9, which is a change of 5. Put this to the first power. And 3 to 10 is 7. And there you have it. All right, except I said I was going to write it a little bit differently. So this is a first dimensional conversion. And when I put a 9 in, I get 9 minus 4 to the first power. Okay, and that's how I'm going to leave it for now. All right, the quadratic. You can see that the pattern emanates from 4, 3, and it's a squaring pattern. So x minus 4 squared plus 3, very similar to what we had before. And now I'm going to have a quadratic conversion of 9 minus 4. And from 3 to 10, 7. Done with that one. Cubic is a little more complicated. And I'm going to have a point of inflection at 4, 3. So I've got x minus 4 cubed plus x minus 4 to the first plus 3. That gets me through 4, 3. And I decided to have a 10 to 1 rate of change. I've got to give a little more information on this one. 10 to 1, so I'm going down at 10 to 1 linearly at that location. And now I've got to get 9 minus 4 cubed out of the picture. And I've got to get to 10. The only way I can get to 10 is from 3 to 10 is to go up 7. However, there's another change here, and that change, I guess I'm going to have to make this g of x over here, start that again, so that I have some room here to write what I need to write. So 9 minus 4 cubed, get that out of the picture. 7 has to come in. And I have to get this out of the picture. So plus 10 times 9 minus 4 to the first power. That's that equation. Exponential, asymptote is 0. So therefore, we'll start from 0 and we'll measure up 3 units to get to 3. And then the next time, I don't go up 3 units. Next time, I go from 0 to 10, 10 thirds. So I'm a little more than tripling. X minus 4. Drop the 9 in, 9 minus 4 for the first power. Okay, that's that function. Asymptote of -2, so we're going to measure change from -2. So g of x equals -2. How do I get from -2 to 3? I go up 5. Next time I don't go up 5, -2 to 10, I go up 12. And I still have my x minus 4 over 9 minus 4. Logarithmic. Well, I see a value of 3. I might go back and look at the zeros and ones that I'm creating. Okay, so I got a y value of 3. How do I get from 3 to 10? Got to go up 7. It's a logarithm. It's got an asymptote of x equals 0. So all I have to do is write x there. I drop in a 4, and I get 4 divided by 4 is 1. Log 1 is 0. 0 takes care of this, which gets me the 3. And I want to get a 9 in there, so 9/4 is the base of that, so that when I drop a 9/4 in, I get value 1 times 7 is 7 plus 3 is 10. Asymptote of -2. G of x. Still going from 3, still going to 10, still a log, but I'm shifting. I'm using transformational language there. I'm shifting my perspective to -2. And that's what I'm measuring from. So when I drop a 4 in, I get 4 plus 2. When I drop in a 9, I get 9 plus 2 over 4 plus 2. And that's my base. So 9 plus 2 over 4 plus 2, that gets me 1. Times 7 is 7 plus 3 is 10. And when I drop in -2, it's undefined. And when I drop in a 4, 4 plus 2 is 6 divided by 6 is 1. Log 1 is 0. 0 times 7 is 0 plus 3 is 3. Absolute value, g of x. Absolute value of x minus 4 plus 3. I'm going to get rid of that absolute value change when I drop in a 9. Okay, that creates the number 1. 1 times 7 is 7 plus 3 is 10. Square root, g of x. X minus 4 plus 3, measuring change from that location. What do I get when I drop in a 9? I get the square root of 9 minus 4. That makes a 1. 1 times 7 is 7 plus 3 is 10. I'll do this one as a cosine curve. So let's go g of x. Cosine is a negative at pi. -1, so I think I'll use that this time. I wouldn't have to, I could have done it more quickly, differently, but let's do it this time this way. So I got to find the midline, 13/2 plus, to get to 3, I've got to go down 6/2, so 6/2 is 3. Why did I pick a fraction? Especially at this stage where my brain is a little tired. 13/2. Well, let's just do this way. So 13/2 to get to having a foggy moment. Let me write this here. 13/2 down to get 6/7/2. So excuse me. So let's write 7/2 cosine. Brain started up again. From here to here is pi units after rotation. Takes 4 to 9, so 9 minus 4, we'll put that there, and we'll go x minus 4 here. And we'll check this out because I want to be at pi. So that becomes a -1, so I drop in a 4. Gets rid of everything except the cosine of pi, which is -1, so -7/2, 13/2 minus 7/2 is 6/2. Okay, that's correct. Or I could have made this a negative and gotten rid of pi. So either one of those would have been fine. All right, woo! Now we'll do it with a sine function. So g of x is equal to still 13/2. We get a minimum at 3 pi over 2. So we'll do it that way first. So here we go. We got ourselves plus 7/2 sine. Sine. A little bit of a change here. 1 pi, 2 pi, 3 pi. 1.5 revolutions takes. From 4 to 9, I'll write 5 this time. X minus 4. And when do I have -1 for a height? So I can go down 7/2 to get to 3. That happens at 3 pi over 2. And if I wanted to change this to a sine function, is there a different way that I could do it? I suppose I could make that a minus and go from pi over 2. That gets the job done. So there's some practice, some conversion practice. And hopefully, you can look at some of the patterns that emanate, and most of them are all about zeros and ones. Maybe we should just check that out a couple of times here. Maybe the square root's a good place to do that one. All right, so what happens when we put 4 in? We get square root of 0 is 0. 0 times anything is 0. There's your C. You get your C that we talked about at the beginning of the video. What happens when you drop a 9 in? The square root of 9 minus 4 is the square root of 5. I'll show that this time. What happens when we divide by the square root of 5? You get the number 1 times 7 is 7 plus 3 is 10. That's happening all over the board. So feel free to go back and see how that happens with the exponential, the logarithmic, etc. I do think it's important that you learn how to do this. I think it explains the types of changes that you're going to see by putting in another coordinate or two. Will be helpful for you as you're just learning this material. And I'll work on my 13 halves minus 7 halves equals 6 halves. Yeah. All right. Okay. See you in a couple of days.